Hello again, and today we're going to look at several sections between mathematics, basic mathematics, and pre-algebra. So we're going to be doing a few things with algebraic terms and a few things with basic mathematical terms. First of all, let's start with our exponential laws. I touched on this in the previous video, but it was with numbers, and of course you can see that these are variables, meaning letters. But we're going to be doing scientific notation, and that's with numbers. But with scientific notation, you have to know these two rules. And I'm sorry, not the power rule, the product rule, sorry. And the power rule doesn't hurt to help, but I mean, help to hurt, whatever. We don't have to learn it. But what I want you to do is I want you to take a picture of this, or you can look, oh Lord, or you can look it up on Google, or you can write them down, or you can take a picture of it, whatever. You will see this in the future. I'm going to go through and do an example of each one, but I'm not doing it because you need to know how to do them to finish this basic math review. I'm doing them because you're going to use the product rule and the quotient rule in what I'm fixing to show you with scientific notation, and you will see the other rules later. And I've actually showed you this rule right here with fractional exponents. Remember in the previous video, the square root of 4 to the first power is equal to 4 to the 1/2 power. So I've actually shown you that one. That one's called fractional exponent or rational exponent. These you will learn in pre-algebra or algebra, depending on which one you're in or reviewing over. These are your algebraic. But I'm going to show you these two because we're going to use those in the scientific notation section, which is going to be the next thing we cover in this basic math review. And basically I'm going to highlight the bases here because that's basically when you have the same base with the exponent and you are multiplying, you use the product rule. If you are dividing the same bases, you subtract the exponents. So what I'm going to do is I'm going to give you two examples to go by here, and then we're going to work some more. So I'm going to go 2 to the 4th times 2 to the 3rd is equal 2 to the 4 plus 3, which is equal 2 to the 7th. That is an example of the product rule. So some of you may remember this back in pre-algebra or whatever. If you are multiplying and the bases are the same, now remember, the bases have to be the same, then you add the exponents. If the bases are the same and you are dividing, 2 to the 5th divided by 2 to the 2nd is equal to 2 to the 5 minus 2, which is equal to 2 to the 3rd. Then you subtract the exponents. But again, the bases have to be the same. And the reason I keep stressing that is sometimes you'll have a test, standardized test, and you'll say x to the 4th divided by y to the 2nd, and y'all will do x to the 4 minus 2 and get x squared, and that is wrong because you cannot do anything when the bases are not the same. Okay, so that's just a little bit of a preview of how you can mess this up, all right? I'm not going to go over the algebraic. I'm not going to go over those until pre-algebra review because I really don't think you need that right now. but check in the pre-algebra review when I get through with it, it should be in there. Okay, so let's work some more problems. So let's go with X, or you have to excuse me, I'm used to doing algebra. 2 to the third times 2 to the negative fourth. Well, don't let the negative 4 mess you up. Again, we are not doing algebra here. We're just doing basic math. So even if I give you a negative exponent, you're still supposed to add and subtract with it. So that will be same base, 2 to the 3 plus a negative 2, 4. And remember in my video, you have $3. You owe $4, therefore you owe $1. Now, for basic math, that's all I want. You could use the inverse rule for those of you that's had algebra, and you can flip that and make it 1 over 2 to the first, which is 1 over 2. If you know how to do that, that's fine. We're not going to get into that right now. We'll get into that with the pre-algebra. Okay, so let's do another one. 5 to the 7th times 5 to the first. Well, that's going to be equal 5 to the 7th plus 1, which is equal 5 to the 8th. Now, I know some of y'all are probably saying, well, this is pretty simple. Well, the reason I'm going over the product rule and the quotient rule is the next slide we're going to go over scientific notation, and we need to make sure you apply the product rule and the product rule and the quotient rule to scientific notation. So let's go with 7 to the 4th power divided by 7 to the 3rd power. Well, that's going to be 7 to the 4 minus 3, which is equal to 7 to the 1st, or just plain 7. So in this case, we used the quotient rule, and we divided with the same base, so that means we subtract the exponent. And then, of course, if we have a negative in there, 8 to the 3rd divided by 8 to the negative 2, that's equal to 8 to the 3 minus a negative 2. And remember our rule from the previous, that turns into a plus. So that means we have 8 to the 5th power. So there are 4 examples, and those are the examples that you will see in scientific notation. Product rule and quotient rule. Now, let's go to scientific notation. Scientific notation is a way to write big numbers and small numbers. But the most important thing to learn about scientific notation is the definition of scientific notation. Now, I'm going to give you a Hubertism definition. Scientific notation is a method of writing very small numbers and very big numbers in science. Okay, that's why it's called scientific notation. But the actual definition is placing the decimal to the right of the first number greater than 0. Now, the first thing you have to do to learn how to do scientific notation is to learn that definition. And why is that? Because if you don't learn this definition, then you're not going to know how to change a number into scientific notation. Well, There we go. You're not going to know how to change it into scientific notation. Now, let's take a couple of examples. And this is a very small number. 0.000516. Now, let me go ahead and tell you something else. 90% of students that I talk to know how to change a decimal into scientific notation and a large number into scientific notation and a scientific notation into a large or a small number. That's not the problem. Where students have the problem is the second part of this presentation, where we actually do operations with scientific notation. And that's where students have a problem. So, pay attention, keep an open mind. I teach this a little bit differently than other teachers do. Then it may work for you, okay? So, the first thing I do, I want to find the first number greater than 0. So which way do we read? In this part of the country, we read from left to right. So the first number greater than 0 is 5, so I'm going to put that decimal right there. So I write 5.16 times 10 to the blank 5. I got 5 humps right there, 5 hops, whatever you want to call them. Notice I did not put a sign. I don't put the sign because I do the sign a little bit different than other teachers. Other teachers say, well, if it's a very small number, it's going to be a negative. And if it's a very big number, it's going to be a positive. I don't do that. Because if you do that, you're going to get confused when you do operations. So I don't do that. What do you do, Hubert? Well, I write a little note down here in green. And I put it right here and I say, mentally means you do it in your head. Ask yourself, which way do I move the decimal to get in original form? Now here is the original form. Which way do I move this decimal in my head to get it back to the original form? To the left. So left is negative. Now this is a part of scientific notation where I differ from other teachers. You will see how this helps you in the operations, okay? Just bear with me. I know that most of you that's watching this have got it patternized. Wherever there's a negative, whenever there's a negative, that means it's a very small number. If it's positive, that means it's a very big number. I don't want you to hold on to that right now, because when we get to the operations, it might make a difference for you. Okay? So if you write this problem, you're going to write it as 5.16 times 10 to the negative 5. 5.16 times 10 to the negative 5th power. And that's your answer. That's scientific notation. So let's get a big number. All right, let's do 4,432,000. Let's use that number. And of course, we know that the decimal is right there, but we want to put the decimal to the right side of the first number start greater than 0. And of course, that's the first number greater than 0. We want the decimal right there. So 1, 2, 3, 4, 5, 6. 4.432 times 10 to the blank 6. Ask yourself, let's get our green marker. Ask yourself, which way do I move this decimal to get it back to the original form, to the right? And that is a positive. And that is the answer to that one. And again, most students don't have a problem with this. course, if I give you a number in scientific notation, you should be able to write it like this. And I'm not going to go into that because a lot of people know how to do that. So if I give you this number, make sure you can write it like a regular number. And I think most of you know how to do that. That's not, again, that's not where students have a problem. So we're going to go into operations now, and we're going to go into where students have problems. Adding and subtracting. That's pretty simple. This is the first time that adding and subtracting is simple with scientific notation. Why? Because it's just like combining like terms in algebra. It's just labels. Notation. I hope I spelled that right. I think I did. All right. Basically, you got to have the same label. If you don't have the same label, then you're going to have to do it with a calculator or change it into decimal form. Okay, let me write that down. Labels have to match. If they don't match, you have to convert to decimal notation and add or subtract. Okay, so let me show you what I'm talking about. If I give you 4.1 times 10 to the 5th, and whether it's a word problem or just asking you, I ask you to add 5.2 times 10 to the 5th. This can be done because these are the same. So they just come down. And you add these two. So that's 9.3 times 10 to the 5th power. Pretty simple. If you're given 8.6 times 10 to the 3rd minus 5.0 times 10 to the 3rd, again, you just take that down and 3.6. So if the labels, and that's what I call the highlighted area, if they're the same, if the terms are the same, you just bring down the terms or the labels. 8 boxes of cereal minus 5 boxes of cereal is 3 boxes of cereal. So the labels don't change, whether you're adding or subtracting scientific notation. If the labels are the same, you just bring it down. Versus 2.6 times 10 to the 3rd plus 3.2 times 10 to the 2nd. You can't do this one because you're going to have to change it into 2, 6, 1, 2, 3 plus 3.2, 1, 2, 320. And now you can do it because you changed it from scientific notation to decimal notation. Or you can do it on a calculator, which I don't advise because I want you to be able to spell mom backwards. Okay, so that's going to come out to be 2320. And now you can change that to 2.3, 2 times 10 to the 3rd power. Now, a lot of people say, well, you just carry the highest exponent. And yes, you can do that, but I like to tell students to, and you don't get you also, now, you could manipulate the 2nd power and change it to 0.32 to the 3rd power, and then you could do it. You could do that, but chances are that's not. Oh, that's supposed to be 2.92. Sorry. 6 and 3 is 9. My bad. There we go. 2.92. And you could do that. What I mean, Hubert, Well, you could do 2.62 or 2.6 times 10 to the third, manipulate this and go 0.32 times 10 to the third, and now you would get, that would come down 10 to the third times 2.92. You could do that, okay? So, you know, there are ways that you can get around doing it, but, you know, check yourself when you do it this way because you might make a mistake over here. So always check yourself to either use the greatest or, you know, or change both into 10 to the third. So that's how you add or subtract scientific notation. Usually you're not tested on that very much on standardized tests. Most of the time you're on the multiplication and the division, which we're going to go over next. So, multiplication and division. Multiplication of scientific notation. You're going to use the product rule. And of course, with division of scientific notation, you're going to use the quotient rule. And the best way to show you is just do an example. So, 2.0 times 10 to the fourth times 4.0 times 10 to the sixth. First of all, you need to realize that you have a equal base. So now I just take 2 times 4 times 10 to the 4 plus 6. And that's going to be 8.0 times 10 to the 10th power. Now, most people say, oh, well, Hubert, that's not a problem. It's not a problem. And most students don't have a problem with doing those. We still haven't got to the problem that I'm telling you about, okay? We still haven't got there yet. When we get there, I'll tell you. All right? So here, let's do another one. Let's do 6 times 10 to the negative 2 times, let's do 1 times 10 to the 8th power. Okay, same thing. We got the same bases. So we can just add the exponents and we get 6 times 1 times 10 to the negative 2 plus 8. We owe $2. We have $8. So we have $6. Well, Hubert, what's the problem? Well, now we're going to do one that is a little bit different. And I'm going to make these small. And I'm going to put 2 on the board, and I want you to pause the video and do them. So that would be 2.0 times 10 to the 4th, 15.0 times 10 to the 6th. And I'll do one more. 6.0 times 10 to the 7th times 3.0 times 10 to the 2nd. All right, take a minute and work on those. Pause the video and we'll come back and do them together. So, come back. 2 times 15 is 30. Not a problem. Times 6 plus 4 is 10. Are we done? No, we're not done. Why? What's the definition of scientific notation? This is not scientific notation. This is regular notation. We've got to change it. So we got to move it one place. 3.0 times 10 to the 10 blank 1. Which way in my head do I move this to get it back the way it was, to the right? And I guarantee you, those of you that's watching this video, I guarantee you somebody came out with the 9th power. The 9th power is wrong. It's 10 to the 11th power. That's where students get the problem wrong. So I'm going to do it again. 6 times 3 is 18. And 7 plus 2 is 9. I've got to move this one place. Notice I don't say anything about which direction. 1.8 times 10 to the 9 blank 1. Which way in my head do I move this decimal to get it back the way it was in the original? To the right? And that's going to be 1.8 times 10 to the 10th power. So if those of you that stopped the video, if you got 3 times 10 to the 11th on the first try, then you're good. If you got 1.8 times 10 to the 10th on the first try, you're good. But if you got to the 9th or to the 8th, that means you've got some work to do. So let's do a quotient rule. Oops. Let's do a quotient rule. Quotient rule says 4.0 times 10 to the 3rd divided by 2.0 times 10 to the 1st. My bases are the same. If my bases are the same, let's highlight the bases. If they're the same, then I can use the quotient rule. The quotient rule says 4.0 divided by 2.0 times 10 to the 3 minus 1. 10 to the 3 minus 1, basically, you're going to have the second power. So that's 2.0 times 10 to the second power. Notice that our decimal is to the right of the first number greater than 1. So therefore, we're done. So let's do another one. Let's do 16.0 times 10 to the 8th over 8.0 times 10 to the negative 1. So that's going to be 16 divided by 8, because our bases are the same right here, times 10 to the 8 minus a negative 1. And remember, that turns into a positive. And that's going to give us 2.0 times 10 to the 9th power. Again, the 2 is, the decimal is to the right of the first number greater than 0, so we don't have to change anything. Again, most of you won't have a problem with these. The one that you will have a problem in is coming up. So we're going to do one like that. So let's do 50 times 10 to the 4th divided by 2 times 10 to the 1st. And then I want you to do another one. Let's do 42 times 10 to the 5th divided by 2 times 10 to the 8th. So pause the video and work those problems out. And when you come back, we will work them together. All right, let's see how you did. 50 divided by 2 is going to be 25. I'm going to go ahead and write that down. And then 10 to the 4 minus 1. So that's going to be 25.0 times 10 to the 3rd. We've got to move this one place. So that's going to be 2.5 times 10 to the 3rd blank 1. Which way do I move this in my head to get it back the way it was? To the right. So that's 2.5 times 10 to the 4th power. So let's do the other one. 42 divided by 2 is 21. Times 10 to the 5 minus 8, which is equal to 21.0 times 10 to the negative 3rd. I've got to move it one place. 2.1 times 10 to the negative 3 blank 1. Which way do I move this in my head to get it back the way it was? To the right. And that's 2.1 times 10 to the negative 2 power. And now you see why people have problems not with 66%, but they only have problems with the 33%, which is the problems that do not come out in scientific notation. And they don't know, they just write the answer is 25 times 10 to the 3rd and 21 times 10 to the negative 3rd, and they get the whole problem wrong, and they only got this little 1% right here. They only got that 1% right there. That's the only thing they got wrong, is that little bit right there. And they did all the problem right, but they got just a little bit wrong because they didn't change it to scientific notation. And see, that's why it's so important that you understand how to do scientific notation. Now, we're going to move into a little bit of algebra now. And we're going to, well, I'm going to go ahead and stop the video, and we'll have another video called algebra. So we'll just go ahead and stop this video right now.